Imagine a mysterious object from deep space speeding towards Mars, only for the world's best telescopes to suddenly go silent just as it passes by. What did they miss? And what secrets does this cosmic visitor truly hold? Every day, thousands watch these cosmic mysteries unfold, but most drift away without joining the mission. Don't just watch the universe, be part of it. Hit that subscribe button and help us uncover the truth that's still hidden among the stars. Before we begin, tell us, what secret of the universe should we uncover next? Drop your thoughts below. But for now, brace yourself. Our newest visitor from the cosmic realm has finally arrived. The story of our strange visitor begins on a day like any other. On July 1st, 2025, astronomers around the world were looking at the stars. They used powerful telescopes, giant eyes that stare into the darkness of space. These scientists spend their nights searching for things that move. They look for asteroids, comets, and new planets. Most of what they find is familiar. It belongs to our solar system, our cosmic neighborhood. But on this day, something new appeared. An alert went out across computer screens in observatories from Hawaii to Chile. It was a faint dot of light, moving in a way that was very, very strange. This was not just another rock. This was something different. The computers flagged it immediately. The object was not following the usual rules of space travel. It was not circling our sun in a long, stretched-out oval like a comet or an asteroid from our own system. Instead, it was cutting straight through. It was like a tourist visiting a city for the first time, not a local walking a familiar path. The news spread quickly through the world of science. Emails were sent, phone calls were made. Everyone wanted a look at this new object. They pointed their biggest telescopes at that one tiny spot in the sky. Every new piece of information made the mystery deeper. This object was not from around here. It came from the vast dark space between the stars. It was a traveller from another solar system, a place we can only dream of. The detection of this object marked a huge moment in our study of the universe. It was a chance to look at a piece of another star's family, right here in our own backyard. For years, scientists had wondered what kind of things existed out there in the great emptiness. Now, a piece of that emptiness had come to visit us. It was a ghost from a faraway place, now visible in our telescopes. The first teams to spot it knew they had found something important. They worked fast to track its movement, to understand where it came from and where it was going. They had to be sure. They checked their numbers again and again. Every calculation told the same amazing story. The object was a true outsider. It was a visitor from interstellar space. This was a moment of pure discovery. It was the kind of thing scientists live for. A new puzzle had just been dropped into their laps, a puzzle that came from light years away. The world's observatories worked together, sharing what they saw. Everyone wanted to help solve the mystery. They knew they were looking at something that might never be seen again. It was quickly given a name, a label to identify this special visitor. The name was 3i Atlas. The name itself tells a story. The I stands for interstellar. This means it came from the space between the stars. The number 3 was also very important. It meant this was only the third such object ever found in all of human history. The first was a strange, cigar-shaped rock called Oumuamua. The second was a more familiar-looking comet named Borisov. And now, there was a third. This made 3i Atlas part of a very exclusive club. It was a rare messenger from the great unknown. Finding one interstellar object is like finding a needle in a haystack. Finding a second one was amazing. Finding a third confirmed that our solar system is not alone. Things from other star systems really do travel through our neighborhood from time to time. The second part of the name, Atlas, came from the telescope system that first found it. Atlas is a set of telescopes in Hawaii designed to spot dangerous asteroids. Its job is to protect Earth. But in this case, it found something far more interesting than a simple space rock. It found a guest from another star. The name 3i Atlas quickly became famous. It was in the news. It was talked about online. People who had never looked at the stars before were suddenly interested in this object. What was it? Where did it come from? What could it teach us? The scientific world was filled with excitement. This was a brand new piece of the universe to study. It was like an archaeologist finding a tool from a lost civilization. This object was a piece of another solar system, and it had brought its secrets with it. But there was confusion too. Early pictures of 3i Atlas were not clear. They were just fuzzy smudges of light. It was hard to tell what it was made of, or even what its shape was. The arrival of 3i Atlas was a grand entrance. It was dramatic. It burst onto the scene and immediately became one of the biggest mysteries in space. It was a lonely traveller that had journeyed for millions, maybe even billions of years through the cold and dark, and now its long journey had brought it here, to us. For astronomers, it was the beginning of a race against time. They had to learn as much as they could about 3i Atlas before it disappeared back into the darkness, perhaps forever. The grand entrance was over. The real work had just begun. One of the first things scientists noticed was its incredible speed. Ground telescopes, the ones on mountains and in deserts here on Earth, tracked its movement across the sky. The numbers they calculated were hard to believe. 3i Atlas was moving at about 124,000 miles per hour. That speed is almost impossible to imagine. It is fast enough to travel from New York to Los Angeles in just over 1 minute. It is many times faster than our fastest rockets. This was not a gentle drift through space. This was a cosmic bullet shot from a gun somewhere far away in our galaxy. This amazing speed was another clue that it was not from our solar system. Objects that belong to our sun travel in curved paths. They are like a ball on a string being swung around a pole. Gravity is the string, and the sun is the pole. The objects are always falling towards the sun, but they move so far sideways that they just keep circling it. They are trapped by the sun's gravity, but 3i Atlas was not trapped. It was moving too fast. The sun's gravity could bend its path a little, like a gentle slope in a road, but it could not capture it. It was like a speeding car passing a small town. It might slow down a little bit, but it was never going to stop. It was just passing through. Its destination was somewhere else. Back out in the deep space between the stars. The telescopes on the ground could see it was heading towards the inner part of our solar system. Its path would take it close to the planet Mars. This was an amazing opportunity. We have spaceships at Mars. We have cameras there. We could get a close-up look. The thought of seeing an interstellar object from one of our own probes was thrilling. Scientists around the world prepared for the flyby. They pointed every telescope they could at this fast-moving target. Every night they would capture its light, trying to learn more. The speed made it a difficult thing to study. It was like trying to take a clear picture of a race car as it zooms past you. But the challenge only made the scientists more determined. They knew this was a once-in-a-lifetime chance. An object from another star, moving at an unbelievable speed, was about to fly right past our robotic eyes on another world. The countdown to the Mars flyby had begun. The evidence was clear. The path of 3i Atlas proved it was a true interstellar traveller. Scientists use math to map out the orbits of objects in space. These orbits are usually ellipses, which are like stretched-out circles. Comets from the edge of our own solar system have very long, stretched-out orbits, but they are still closed loops. They will eventually come back towards the Sun, even if it takes thousands of years. But the path of 3i Atlas was not a closed loop. It was an open curve, a shape called hyperbola. This is the telltale sign of an object that is not bound by our Sun's gravity. Imagine drawing a line in the sand. An orbit in our solar system is like drawing a circle or an oval. You always come back to where you started. The path of 3i Atlas was like drawing a line that just keeps going straight off the beach and into the ocean. It was not coming back. This mathematical proof was the final confirmation. 3i Atlas was not one of ours. It was born around another star in a solar system we have never seen. It was ejected from its home long ago, perhaps by the gravity of a giant planet. Since then, it has been wandering the galaxy, a lonely piece of cosmic driftwood. For millions of years, it travelled in silence and darkness. Then, by pure chance, its path crossed ours. Our solar system is a tiny island in a vast cosmic ocean. The fact that this traveller happened to float by our island was incredibly lucky. It gave us a direct sample from a place that is too far away to visit with our own ships. We could study its light, learn what it was made of, and get clues about the place where it was born. The confirmation that it was an interstellar object was a huge moment. It changed the way we think about the space between stars. That space is not completely empty. It is filled with these travellers, these messengers from other worlds. And now, one of them was here, offering us a chance to learn its secrets. Its path was a clear message, written in the language of physics. The message said, "I am not from here, I am just passing through." As 3i Atlas got closer, everyone wanted a better picture. We have amazing technology on and around Mars. NASA's Perseverance rover is like a robotic scientist on the ground. It has powerful cameras that can look up at the Martian sky. From its spot on the surface, it could see 3i Atlas as a moving star. The rover took pictures. So did the orbiters, the spaceships that circle high above Mars. These first images were sent back to Earth. The world waited to see what this visitor looked like up close. But the pictures were not what people hoped for. They were blurry. They were confusing. 3i Atlas did not look like a sharp, clear object. It was a fuzzy blob of light. It was a ghost in the machine. In some images it looked long and stretched out. In others, it just looked like a hazy cloud. This sparked a lot of debate among scientists. What was its true shape? Why was it so hard to see clearly? Was it a solid rock, like Oumuamua was thought to be? Or was it more like a classic comet, a ball of ice and dust with a glowing cloud around it? The early images did not give a clear answer. They only gave more questions. The blurriness was a problem, but it was also a clue. It told scientists that this object was not a simple dead rock. It was active. Something was coming off its surface, creating a cloud that hid its true form. This cloud, called a coma, is what makes comets look fuzzy. But the cloud around 3i Atlas seemed different somehow. It did not behave like a normal comet's coma. The initial debates were just the beginning. The confusing first pictures set the stage for a much deeper mystery. Everyone hoped that as it got even closer to Mars, our cameras would get a better look. They hoped the blur would sharpen into a clear image, revealing the heart of this interstellar traveller. They wanted to see the object itself, not just the cloud it was hiding in. The world watched and waited, hoping for clarity. But what they got instead was something no one expected. The blurriness was nothing compared to the silence that was about to come. The silence from NASA, the impossible path, and the unbreakable nature of 3i Atlas. Are these just strange coincidences, or something far more deliberate? Now we turn to the days the world was waiting for, the moment of truth. In early October of 2025, 3i Atlas was scheduled to make its closest approach to Mars. This was the peak of the event. It was our best chance to see this interstellar visitor up close. Scientists, journalists, and space fans all over the world were glued to their screens. They expected a flood of amazing pictures and data. NASA has a fleet of powerful spacecraft at Mars. The Mars Reconnaissance Orbiter has a camera so sharp it can see things on the ground as small as a dinner table, all the way from space. Surely a camera like that could get a stunning picture of 3i Atlas as it flew by. Everyone expected breathtaking images, showing details of the object's surface, its shape, and the cloud of gas and dust around it. We would finally see the heart of the mystery. The orbiters also have special tools to study the chemicals in the gas cloud. They could tell us what 3i Atlas was made of. This information would be priceless. It would be like reading a page from a history book about another solar system. The excitement was at a fever pitch. NASA's websites, where they post all the latest pictures from their missions, were being refreshed every few seconds by people all over the planet. They were waiting for that first, incredible, high-resolution image to appear. They were ready to be amazed. This was NASA's moment to shine. They had the best tools in the best place at the best time. The world was watching, expecting NASA to deliver a clear view of this messenger from the stars. It was a chance for a historic discovery, broadcast live for the whole world to see. But the pictures never came. The data never arrived. Instead of amazing images, the world was met with a strange and sudden wall of silence. The moment of discovery turned into a moment of deep confusion. Instead of incredible new photos, something very strange happened. As 3i Atlas swept past Mars, NASA's websites suddenly went down. People trying to see the latest updates were met with error messages. The pages would not load. The live data feeds from the Mars spacecraft, which usually show a constant stream of information, went completely dark. It was as if someone had just flipped a switch. For 2 critical days, October 3rd and 4th, the public heard nothing. These were the very days when 3i Atlas was at its closest point to Mars. This was the most important time for observation. And at that exact moment, all of NASA's public information systems failed. It was not just one website, it was all of them. The image galleries for the Perseverance rover, the Curiosity rover, the Mars Reconnaissance Orbiter, all of them went blank. No new pictures, no new data, nothing. The silence was deafening. In the age of instant information, a complete blackout from the world's leading space agency was shocking. People started asking questions online. Was there a technical problem? Did a solar flare damage the spacecraft? Was there an accident? But NASA offered no immediate explanation. There were no press releases, no updates on social media, just silence. This fueled all sorts of speculation. The timing was just too perfect to be a coincidence. For weeks the world had been counting down to this exact moment, and then, at the climax, the show was cancelled without any warning. It felt like watching a movie that cuts to black right before the big reveal. The frustration was immense, but it was mixed with a growing sense of suspicion. Why would NASA go silent at the most important moment? What was happening behind the scenes? The lack of information was more dramatic than any picture could have been. It created a vacuum, and into that vacuum all sorts of wild ideas began to rush in. The unexplained silence became a bigger story than the comet itself. The critical period was short. The close flyby of Mars was a brief window of opportunity. The two most important days were October 3rd and 4th, 2025. During this 48-hour period, 3i Atlas would be closer to our robotic eyes than it ever would be again. This was the golden window. This was when we could get the best resolution, the sharpest details, the most precious scientific data. And during that entire window, not a single piece of new public data came from any American spacecraft at Mars. It was a total information blackout. The public feeds, which are normally updated regularly with new images and reports, showed nothing new. The last images were from before the flyby. The next images came only after 3i Atlas was already pulling away, getting farther and farther from Mars. The best moments were missed, at least by the public. We saw the before, we saw the after, but we were not allowed to see the during. This was deeply frustrating for everyone who had been following the story. It was like being promised a front row seat to a spectacular concert, only to have the curtains closed right as the main act walked on stage. The silence from the American side was complete. The world's most powerful and expensive set of eyes at Mars was effectively blind to the public. Scientists outside of NASA were just as confused as everyone else. They were counting on that data for their own research. They had planned studies based on the high-resolution images they were expecting. But the data never came. Their plans were put on hold. They were left to wonder what, if anything, NASA had seen. The absence of information was a powerful statement. It suggested that something had happened, something that officials did not want the public to see or know about. The 2 days of silence on October 3rd and 4th became the heart of the conspiracy theories. What was so special about those 2 days? What did NASA see that made them shut everything down? The questions piled up with no answers in sight. Finally, after days of silence and growing public pressure, NASA gave an official reason for the blackout. They blamed a United States government shutdown. According to the statement, a disagreement in Congress about the national budget had forced large parts of the government to close. This shutdown began on October the 1st, just hours before the flyby. NASA, being a government agency, was forced to halt all operations that were considered non-essential. This included public outreach, website updates, and processing new data for public release. The official story was that the timing was just incredibly bad luck. The political fight in Washington, D.C. had accidentally caused a scientific blackout 140 million miles away. On the surface, this explanation seemed possible. Government shutdowns had happened before, and when they do, many government services stop. National parks close, website updates are paused. It was believable that NASA's public relations department would be sent home. So, the story was that the spacecraft themselves were still working. The orbiters and rovers were still collecting data. But the people on Earth whose job it was to process that data and put it on the website were not allowed to work. The data was being stored, they said, but it could not be shared until the shutdown was over. To many people, this explanation felt thin. This was not just any day. This was the flyby of a once-in-a-generation interstellar object. It was a major global scientific event. Could it really be considered non-essential? Many people found it hard to believe. They questioned why an exception could not be made for an event of such importance. Why couldn't a small team be kept on duty to handle this unique situation? The government shutdown explanation seemed too convenient. It was a perfect excuse to hide something, if someone wanted to. It was an official reason that was hard to argue with, yet it felt deeply unsatisfying. It did not make the mystery go away. It only made it deeper. The situation became even stranger when people looked at what other space agencies were doing. While NASA was silent, the European Space Agency, or ESA, was not. The ESA also has a spacecraft orbiting Mars called the Mars Express. It is an older probe, and its camera is not as powerful as NASA's best. But it was still there, and it was still working, and more importantly, the ESA was still talking. The European agency was not affected by the US government shutdown. Their operations continued as normal. During the flyby, the ESA released a constant stream of updates. They posted the new images they got from the Mars Express. They were blurry because the camera was not as good, but they were something. They were proof that it was possible to track the object. The ESA also shared their data on the object's path and the chemicals they were detecting. They were open and transparent. They shared what they had when they had it. This made NASA's silence look even more suspicious. If the Europeans could continue their work, why couldn't the Americans? It showed that the flyby event was not impossible to cover. The contrast was stark. On one side, you had the ESA sharing fuzzy pictures and being open with the world. On the other side, you had NASA, with their superior high-tech cameras sharing absolutely nothing. This comparison made the government shutdown excuse look even weaker. People started to think, if the ESA saw something, even with their weaker cameras, what must NASA have seen with their powerful ones? The open communication from Europe highlighted the closed doors in America. It made it seem like NASA was not just a victim of bad political timing. It made it seem like they were actively hiding something. The actions of the European Space Agency proved that observation was possible. So the question remained, why did NASA choose to stay silent? The world had no clear answers, only more and more questions. The Blackout was an event that would cast a long shadow over the entire story of 3i Atlas. From the very beginning, one of the biggest challenges with 3i Atlas was just trying to get a good look at it. Even with our most powerful telescopes on Earth and in space, all the images of this visitor were fuzzy. They were not the sharp, detailed pictures we are used to seeing of planets and moons. Instead, 3i Atlas looked like a faint streak of light, a ghostly smudge against the black background of space. It was like trying to take a picture of a firefly in a dark forest from a mile away. You might see a little blip of light, but you could not make out the shape of the insect itself. This blurriness was a source of great frustration for astronomers. They wanted to see the object at the heart of the fuzz, the solid part called the nucleus. But it remained hidden. The faintness of the object was part of the problem. It was very far away, and it was not very bright. It did not reflect a lot of sunlight. So, to even see it at all, astronomers had to use long exposure times on their cameras. A long exposure is like leaving the shutter of a camera open for a long time to let more light in. It is what you do when you take pictures of stars at night. You might leave the shutter open for many seconds, or even minutes, to capture the faint starlight. This technique works great for things that are standing still. But 3i Atlas was not standing still, it was moving incredibly fast. So, while the camera's shutter was open, the object itself was streaking across the frame. This created a smear effect. Think about trying to take a picture of a moving car at night. If you use a long exposure, you will not get a clear picture of the car. You will get a long red streak from its taillights. The same thing was happening with 3i Atlas. Its own speed was smearing its image, making it look like a blurry line. This is why many of the pictures showed it as an elongated shape. It was an illusion created by its own motion. The need for long exposure times was a basic problem of physics. Capturing light from a dim, distant target requires patience. The camera's sensor needs time to soak up enough photons, the tiny particles of light, to create an image. For a bright object like the moon, you only need a fraction of a second. But for a faint comet on the edge of the solar system, you need minutes or even hours of exposure. 3i Atlas was a very challenging target. It was not big, and its surface was probably very dark, meaning it did not reflect much sunlight. So, to get any picture at all, telescopes had to stare at it for a long time, keeping their electronic eyes wide open. During this time, every single particle of light that hit the detector was recorded. This slow and steady collection of light is what allows us to see things that are billions of miles away. It is a powerful tool, but it has a major weakness when the target is moving quickly. The long exposure time that was necessary to see 3i Atlas at all was also the very thing that made the images blurry. It was a trade-off with no good solution. If they used a short exposure time, they would get nothing but blackness, because not enough light would be collected. If they used a long exposure time, they would get a picture, but it would be a smeared, blurry streak. Astronomers did their best to work around this. They used advanced computer programs to try and de-blur the images. These programs can try to correct for the motion and sharpen the picture, but there is only so much they can do. It is like trying to unscramble an egg. You can never get it back to the way it was. So, the blurriness remained. It was a fundamental limit of our technology when faced with an object this faint, this far, and this fast. We could see that something was there, but we could not see exactly what it was. The heart of the mystery remained shrouded in a blur of its own making. The problem was made worse by the object's incredible speed. As we mentioned, 3i Atlas was travelling at about 124,000 miles per hour. That is a speed that is hard to comprehend. During a single 30-minute camera exposure, the object would travel almost 62,000 miles. That is more than twice the distance around the entire Earth. So the object was not in the same place at the end of the picture as it was at the beginning. It had moved a significant distance across the sky. This movement is what smeared its image across the camera's sensor. The telescope was programmed to follow the object, to keep it in the centre of the frame. But even with perfect tracking, the object's own movement relative to the background stars would cause some smearing. The result was that all the images looked elongated or stretched out. This led to a lot of early confusion. Some of the first reports speculated that 3i Atlas might have a very strange shape, like the cigar-shaped Oumuamua. People wondered if we were looking at a long, thin object, but most scientists soon realized that this was probably an illusion. The long shape was not the shape of the object itself. It was the shape of its path across the camera during the time the picture was being taken. It was a visual trick, a ghost in the machine. This smearing effect made it impossible to determine the true shape of the object just by looking at the pictures. Was it round like a ball? Was it irregular like a potato? Was it long and thin? The images could not tell us. The speed that made 3i Atlas so interesting was also what made it so hard to study. It was like a shy animal that runs away as soon as you try to get a good look at it. This visitor from another star was not making it easy for us. It was a ghostly target, always on the move, never staying still long enough for us to get a clear portrait. The blurriness was a constant reminder of how challenging it is to study these rare visitors from the depths of space. Even with our most advanced instruments, the solid body at the centre of 3i Atlas remained invisible. This central part of a comet is called the nucleus. It is the heart of the object, the source of all the gas and dust that forms the glowing cloud around it. Seeing the nucleus is the key to understanding the comet. Its size, shape and colour can tell us a lot about where it came from and what it is made of. But in the case of 3i Atlas, the nucleus was completely hidden. It was surrounded by a diffuse hazy cloud of gas and dust. This cloud is called the coma. For 3i Atlas, this coma was very effective at hiding the object within. No matter how hard astronomers tried, they could not peer through the haze. Even the Hubble Space Telescope, one of the most powerful telescopes ever built, could not get a clear view of the nucleus. All it saw was the same fuzzy blob of light. It was a brighter, slightly clearer blob, but it was still a blob. There was no sign of a solid object at its centre. This was unusual. For many comets in our own solar system, we can eventually get a good look at the nucleus, especially when our spacecraft fly close to them. But 3i Atlas kept its heart a secret. It just appeared as this hazy cloud, a ghost without a solid form. This meant that scientists could not directly measure its size. They had to estimate it based on how bright it was, but that was just a guess. The lack of a visible nucleus was a major puzzle. Why was it so well hidden? Was the coma unusually thick and dense? Or was the nucleus itself very small or very dark, making it hard to see? Or was there another stranger possibility? Could the object be something other than a simple solid nucleus? The inability to see its core just added another layer to the growing mystery. We could see the cloud, but we could not see what was making the cloud. We were stuck on the outside looking in. The true nature of 3i Atlas was still a complete unknown, hidden inside a veil of its own dust. Because they could not see the object directly, scientists had to use other, more clever methods to learn about it. They had to become detectives, looking for indirect clues. One of the most powerful tools they have is called spectroscopy. This is a way of studying light. When light from an object passes through a special instrument, it gets split up into a rainbow of different colours, called a spectrum. But this spectrum is not just a smooth rainbow. It has dark or bright lines in it. These lines are like a chemical fingerprint. Each chemical element, like hydrogen, oxygen, or iron, creates its own unique pattern of lines. By studying the lines in the spectrum of light from 3i Atlas, scientists could figure out what chemicals were in its hazy cloud. It was like analysing the smoke from a distant fire to figure out what is burning. This method told them a lot. They could see the signs of familiar comet chemicals, which gave them some comfort that this was, in some ways, a normal comet. Another method they used was to study how the object scattered sunlight. As sunlight hits the dust particles in the coma, it bounces off in different directions. By measuring the brightness of the object from different angles, scientists could get clues about the size, shape, and texture of those tiny dust particles. It is like trying to figure out the shape of an object in a dark room by just shining a flashlight on it and seeing how the light reflects. These indirect methods were all they had. They could not rely on a simple photograph. They had to piece together the story of 3i Atlas from these faint and complicated clues. It was slow and difficult work. Each new piece of data had to be carefully analysed. But it was the only way to learn about this mysterious visitor. They were studying a ghost, so they had to use ghostly methods. They were listening to the faint whispers of light coming from the object, trying to translate them into a language we could understand. The picture of 3i Atlas that began to form was not from a single, clear image, but from hundreds of these tiny, indirect clues, all put together like a giant cosmic puzzle. What truly baffled scientists was the path 3i Atlas took through our solar system. It was an impossible path, a route that a visitor from deep space should not take. This part of the mystery made 3i Atlas stand out from everything that had come before it. Previous interstellar visitors, the rock known as Oumuamua and the comet Borisov, had behaved as expected. They plunged into our solar system from high above or far below, at very steep angles. Imagine our solar system is a flat dinner plate, with the sun in the middle and the planets circling around it on the plate's surface. This flat area is called the ecliptic plane. Oumuamua and Borisov were like insects flying into the room and diving down towards the plate from the ceiling, or coming up from under the floor. Their paths were random, which is what you would expect from objects that have been wandering the galaxy for billions of years. They came in at whatever angle their long journey happened to give them. But 3i Atlas was different. It did not dive in from a steep angle. Instead, its movement was remarkably flat. It was as if this interstellar tourist decided to use the same highway that all our planets use. It came in almost perfectly aligned with the ecliptic plane. It was moving like it belonged here, even though we knew it did not. This was strange. It was very, very strange. For a random object from deep space to arrive on such a precise flat path was like throwing a paper airplane from a skyscraper and having it glide perfectly through the open door of a specific car driving on the street below. It was possible, but the odds were incredibly low. This strange route was the first major clue that there was something more to 3i Atlas than just a random piece of space rock. Its path seemed too neat, too orderly, too deliberate. It was a path that defied all expectations, and it sent a shiver of curiosity through the scientific community. The impossible path of 3i Atlas was a puzzle that demanded an explanation. The path of 3i Atlas stayed remarkably close to the ecliptic plane. This is the flat highway, where all the planets in our solar system orbit the Sun. From Mercury out to Neptune, all the major planets travel in roughly the same flat disk. It is a defining feature of our solar system, a result of how it formed from a spinning cloud of gas and dust billions of years ago. Our cosmic neighbourhood is organised and orderly. By contrast, the space between the stars is not. It is a chaotic, random place. Objects out there should be moving in all directions. So, when an object from that random place enters our orderly neighbourhood, we expect it to look like an outsider. We expect it to have a random, tilted path. But 3i Atlas did not. It slid into our system almost perfectly flat, as if it knew the local traffic rules. It was like a tourist from another country who somehow knows all the local backroads without ever looking at a map. This was a major red flag for astronomers. It was a statistical anomaly. That is a scientific way of saying it was a huge coincidence, so big that it might not be a coincidence at all. The ecliptic plane is a very thin slice of the sky. The chances of a random object from deep space just happening to line up with that thin slice are extremely small. It would be much more likely for it to come in from above, below, or any other angle. The fact that it chose this specific orderly path was deeply puzzling. It suggested that maybe this was not a random event. Maybe there was some reason for its path being so perfect. This was the point where some scientists started to wonder if this object was more than just a simple comet. Its path was too good to be true. It was the path of an object that seemed to know where it was going. It was moving with a strange sense of purpose, staying on the main road of our solar system, almost as if it had a destination in mind. For an object from deep space, coming in on such a flat, precise path is incredibly rare. Scientists who study orbits have calculated the odds. The chance of a random interstellar object having an orbit so closely aligned with our solar system's plane is less than 1%. It is a very unlikely thing to happen. Some calculations put the odds even lower, much lower. This is not just a small curiosity. It is a major scientific puzzle. When something happens in science that is very, very unlikely, scientists have to ask why. Is it just dumb luck? Or is there a physical reason for it that we do not understand yet? Could there be some unknown force in the galaxy that guides objects onto these flat paths? Or is there another, more startling explanation? The rarity of this event cannot be overstated. We have only ever seen 3 interstellar objects. For one of them, this one, to have such a strange and unlikely orbit is a big deal. If we had seen 100 interstellar objects and only one of them had this flat path, we might dismiss it as coincidence. But with such a small number of visitors, having one that is so weird makes it stand out even more. It is like meeting only 3 people from a newly discovered country, and one of them is a 7-foot-tall giant who can speak perfect English. You would immediately think there is something special about that person and that place. Scientists were forced to confront this strange fact. The orbit of 3I Atlas did not fit the pattern. It broke the rules of what we expected an interstellar visitor to do. It was a statistical outlier, a piece of data that just did not fit on the chart. And in science, it is often the outliers, the things that do not fit, that lead to the biggest discoveries. The impossible path was telling us something. The challenge was to figure out what that message was. The object's strange tour did not stop there. Its path seemed almost like a carefully planned trip through our solar system, designed to visit some of its most interesting places. The trajectory of 3I Atlas brought it close to Mars first. This was the moment of the controversial NASA blackout. After passing Mars, its path was set to bring it close to Earth. It would not be close enough to be a danger, but it would be close enough for all of our powerful telescopes on the ground and in orbit to get another good look. It was like the object was making a second pass for our cameras, and the tour was not over. After swinging by Earth, its path would carry it outwards, towards the giant planets. Eventually it would pass near Jupiter, the king of our solar system. This sequence of close passes was also very strange. It was like a greatest hits tour of our solar system. First Mars, then Earth, then Jupiter. It was an incredibly efficient path for any spacecraft that wanted to study these 3 important worlds. A probe designed by NASA would have a similar trajectory if it was on a mission to explore the outer solar system. This similarity was not lost on the scientists who were studying it. The path was not just flat. It was also conveniently planned to visit key locations. It was another coincidence, another piece of the puzzle that did not seem to fit. A random rock should not have such a scenic route. It should just pass through on a simple, uninteresting curve. But 3I Atlas seemed to be hitting all the landmarks. This led to even more speculation. Could this path be artificial? Was it possible that the object was not just a comet, but a probe, deliberately sent on this specific path to gather information about our solar system? This was a wild idea, but the path was so strange that even wild ideas had to be considered. The grand tour of 3I Atlas was another anomaly, another reason to suspect that this visitor was something very special. Experts in the field, like the famous Harvard astronomer Avi Loeb, have spoken out about how strange this is. Avi Loeb is known for his bold ideas, especially his theory that our first interstellar visitor, Oumuamua, might have been an alien technology. When 3I Atlas arrived, he was one of the first to point out how truly bizarre its orbit was. He and other scientists did the math. They calculated the probability, the chance of an object from deep space having a path that was both so flat and so conveniently aligned to fly by Mars, Earth, and Jupiter. The number they came up with was astonishingly small. They said the chances of this happening naturally are less than 1 in a million. When a scientist says something is a 1 in a million chance, you should pay attention. It means that if you watched 1 million interstellar objects fly through our solar system, you would expect to see only one of them behave like 3I Atlas. But we have not seen 1 million. We have only seen 3. This makes the statistics even more troubling. The fact that we saw such a rare path so early in our search for interstellar objects is deeply weird. It is like buying your first 3 lottery tickets ever, and one of them is the grand prize winner. You would probably suspect that the lottery was rigged. Avi Loeb and others have argued that when something seems this unlikely, we have to be open to the possibility that it is not natural. We have to consider the idea that it might be artificial, that it was designed by an intelligence. This is a controversial idea, and many scientists disagree with it. They say we should look for a natural explanation first, no matter how strange it seems. But the path of 3I Atlas is so hard to explain naturally that it forces us to think about other possibilities. Its trajectory is a major puzzle. It is one of the strongest pieces of evidence that suggests 3I Atlas is not just a simple comet. It is a clue that points towards something far more profound and perhaps far more disturbing. Another huge piece of the puzzle was the object's weight. After observing how its path was slightly bent by the gravity of the Sun and planets, scientists were able to estimate its mass. The number they calculated was shocking. They estimated that 3I Atlas weighs around 33 billion metric tons. This number is so big it is hard to wrap your head around. A metric ton is about the weight of a small car. So imagine 33 billion cars all packed together into one object. That is the incredible mass of 3I Atlas. This made it much, much heavier than any other interstellar comet or asteroid we have ever seen. Comet Borisov, the second interstellar visitor, was a more typical size, maybe a few million tons. But 3I Atlas was thousands of times heavier. It was a true heavyweight, a giant compared to other comets. Its size was completely off the charts. It was an anomaly not just in its path, but in its very substance. This huge mass was another reason it was so hard to explain. Where could such a massive object come from? How could it be kicked out of its home solar system and sent on a journey through the stars? Usually it is the smaller things that get thrown out of a solar system during its chaotic youth. Big things tend to stay put, but 3I Atlas was a monster. Its mass was more like a small moon than a typical comet. This discovery added to the growing feeling that this object was breaking all the rules. It was too fast, its path was too perfect, and now it was far too heavy. Each new piece of information made the mystery deeper. The sheer weight of 3I Atlas was a problem for all the existing theories. A normal comet should not be this big. It challenged our ideas about how comets are formed, not just in our solar system, but everywhere in the galaxy. This heavyweight anomaly was a clue that we were dealing with something entirely new, something our science had not yet imagined. One of the defining features of a comet is that it is not just a dead rock. It is an active object. When a comet gets close to the Sun, the heat warms up its surface, turning ice into gas. This gas streams away from the comet, creating the glowing cloud or coma and the long tail that comets are famous for. This process is like a rocket engine. The gas shooting off in one direction pushes the comet in the opposite direction. This is called outgassing, and it can actually change a comet's path. For small comets, this push from the outgassing can be very noticeable. It makes their orbits a little unpredictable. Scientists saw that 3I Atlas was also active. Gas was streaming from its surface. They could see the coma, the hazy cloud around it, so they expected to see its path change a little bit. They expected the outgassing to give it a slight push, altering its perfect trajectory. But that is not what happened. Even though gas was clearly coming off its surface, its path barely changed at all. It stayed on its precise, predictable course. This was very unusual. The reason its path did not change was its incredible mass. It was so heavy that the gentle push from the escaping gas was not enough to move it. It was like trying to push a giant cruise ship by blowing on it. The force was just too small to have any effect on such a massive object. This observation was another important clue. It confirmed that the object was truly, incredibly massive. The lack of change in its path, despite the visible outgassing, meant that it had a huge amount of inertia. It was an unstoppable force moving along its determined path, unaffected by the normal forces that push comets around. This stability was another thing that made it seem less like a natural, fragile comet, and more like a solid, well-built object. It was a heavyweight that shrugged off forces that would have sent a smaller comet tumbling. The fact that 3I Atlas was so massive and so solid raised a big question. It suggested that this object was far denser than a typical comet. Comets are often described as dirty snowballs or icy rubble piles. They are thought to be loose collections of ice, dust and rock, not very tightly packed together. They are fragile. We have seen comets in our own solar system break apart as they get close to the Sun. The heat and gravity can tear them to pieces. But 3I Atlas seemed to be made of tougher stuff. To have that much mass packed into the size it appeared to be, it had to be much denser than a normal comet. It was not a fluffy pile of rubble. It was something more solid, more substantial. This suggested it might have a different origin. Perhaps it was not formed in the cold outer reaches of a solar system, where comets are usually born. Maybe it came from closer to a star, where things are more rocky and dense. Or maybe it was not natural at all. A dense, solid object is much better suited for long-distance travel through interstellar space. A fragile rubble pile might not survive the journey, so its density could be a clue to its purpose. This was another piece of evidence that made some people think of an engineered object, a probe designed to be tough and durable. Of course, there could be a natural explanation. Maybe some solar systems produce comets that are much denser than the ones we're used to. But we had never seen one before. Once again, 3I Atlas was showing us something new and unexpected. It was not just its path or its mass, but its very structure that seemed strange. It was a cosmic cannonball, not a dirty snowball. And that difference was a critical part of its mystery. The existence of a giant like 3I Atlas created a major headache for astronomers, a problem they call the missing Pebbles problem. It is a simple but powerful question. If nature can create a huge interstellar object like 3I Atlas, which weighs 33 billion tons, then it must have created many more smaller objects. For every giant boulder, there should be thousands of medium-sized rocks and millions of tiny pebbles. That is just how nature works. When you break a big rock, you get many more small pieces than big pieces. The same should be true for objects that get kicked out of solar systems. We should see far more small interstellar visitors than big ones. But that is not what we are seeing. So far, our 3 interstellar visitors have been Oumuamua, a medium-sized object, Borisov, a fairly normal-sized comet, and 3I Atlas, a true giant. We are not seeing the flood of smaller interstellar rocks and comets that our theories predict. We have found the giant boulder, but we cannot seem to find the thousands of pebbles that should be accompanying it. So, where are all the missing pebbles? This is a deep puzzle. It suggests that our understanding of how these objects are created and travel through space might be wrong. Maybe small objects are harder to detect than we think. Or maybe they get destroyed on their journey more easily than the big ones. Or maybe, just maybe, the big objects like 3I Atlas are not part of the same natural family as the smaller ones. Maybe the giants are made in a different way. The missing pebbles problem casts doubt on the idea that 3I Atlas is just a rare natural giant. Its existence, without a crowd of smaller relatives, makes it look even more special and even more out of place. It is like finding a single, giant elephant footprint in a desert, with no other tracks of any kind for miles around. It makes you wonder how it got there, and if it is really what it seems to be. The sheer size and stability of 3I Atlas present a major challenge to our understanding of how comets are formed and how they behave. Our current models of solar system formation are based on what we see in our own neighbourhood. We believe comets are leftovers from the birth of the planets, ancient icy bodies that live in the cold darkness of the outer solar system. We think of them as being relatively small and fragile. But 3I Atlas does not fit this model. It is too big, too dense, and too tough. It forces us to reconsider our theories. Could it be that other solar systems are very different from ours? Do they produce giant, super-dense comets on a regular basis? If so, why? What kind of planetary system creates monsters like this? This is a fundamental question about our place in the universe. Are we living in a typical solar system, or a strange one? Studying objects like 3i Atlas is our only way to find out. Another possibility is that our understanding of how comets behave is incomplete. We see 3i Atlas surviving a close pass to the Sun, shrugging off the heat and outgassing with no problem. This incredible stability is unlike any comet we have ever studied up close. It suggests a level of internal strength that is hard to explain for a loose pile of ice and dust. This challenges our models of cometary physics. We may have to rewrite our textbooks based on what this one object is showing us. The mystery of 3i Atlas is not just about one strange object, it is about our entire picture of the cosmos. This single visitor has the potential to shake up our most basic ideas about how solar systems are built and how they work. Its massive size and its unshakable stability are two of the biggest clues. They tell us that the universe is more complex and more surprising than we ever imagined. And they hint that the true nature of this heavyweight anomaly might be something beyond our wildest dreams. When scientists studied the light from 3i Atlas, they found a strange mix of chemicals, a fingerprint that was both familiar and bizarre. Using their special instruments, they could see the chemical signs of cyanide and carbon monoxide in the gas cloud around the object. On the one hand, this was reassuring. These are common chemicals found in the comets of our own solar system. Cyanide, while poisonous to us, is a simple molecule made of carbon and nitrogen, and it is often seen in space. Carbon monoxide is also a very common gas. Finding these familiar substances suggested that, on some level, 3i Atlas was made of the same basic building blocks as our own comets. It was like meeting a visitor from a foreign country who, despite looking different, speaks a few words of your own language. It created a connection. It suggested that the chemistry of the universe might be similar everywhere. The building blocks for comets, and maybe even for life, could be the same in other solar systems as they are here. This was an exciting idea. It hinted that the processes that formed our solar system are not unique. But this was only part of the story. While the gas told a familiar tale, the dust told a very different one. The chemical clues were pointing in two different directions at once, creating a conflicting and confusing picture. The mystery was not just what chemicals were there, but how they could all be there at the same time in the same object. This chemical puzzle would become one of the most intriguing aspects of the 3i Atlas mystery. The object was a paradox, a mix of the ordinary and the extraordinary. And that strange mix was a powerful clue to its true origin. While the gas seemed familiar, the dust that was shedding from 3i Atlas told a completely different story. By studying how the dust scattered sunlight, scientists found evidence of something called silicate grains. Silicates are minerals that make up rock. They are the main ingredient of the sand on our beaches and the rock under our feet. Finding silicate grains in the dust from 3i Atlas was a big surprise. These types of rocky minerals are usually formed in warm environments, close to a star. They are what planets like Earth and Mars are made of. They are not what you expect to find in a comet, which is supposed to be an icy body formed in the cold outer edges of a solar system. This was a major contradiction. The gas was telling us it was a cold, icy comet. The dust was telling us it was a warm, rocky object, more like a piece of a planet. How could it be both at the same time? It was like finding a polar bear in the middle of the Sahara Desert. It just did not belong. This discovery sparked intense debate. Some scientists tried to find ways that rocky dust could end up in an icy comet. Maybe the solar system where it formed was very chaotic, with materials getting mixed up in strange ways. But it was a difficult idea to support. The more straightforward explanation was that 3i Atlas was not a simple comet. It was something more complex, something with a history that involved both hot, rocky places and cold, icy places. This could mean it was a fragment of a planet that had both a rocky surface and an icy mantle, or it could be something else entirely. The presence of these silicate grains was a clue that pointed away from a simple, natural comet origin. It hinted at a much more complicated and interesting past. It was another piece of the puzzle that just did not fit, pushing the mystery of 3i Atlas into even stranger territory. The chemical story got even weirder. Detailed analysis of the light from 3i Atlas revealed another strange imbalance. It had a lot of the element nickel, but at the same time it had almost no iron. This was a huge red flag for scientists. In nature, nickel and iron almost always go together. They are like cosmic brothers. They are forged together in the hearts of dying stars. When asteroids and meteorites are formed, they contain both nickel and iron, usually in a predictable ratio. Our own planet Earth has a core made of both iron and nickel. To find an object in space that was rich in nickel but poor in iron was bizarre. It was like finding a forest with lots of squirrels but no nuts. It goes against the normal rules of cosmic chemistry. Where did all the iron go? And why was there so much nickel? This strange chemical signature had never been seen before in any comet or asteroid in our solar system. It was unique to 3I Atlas. This discovery stumped the experts. They had no good natural explanation for this separation of nickel and iron. In an industrial setting here on Earth, we can separate elements like this. We have chemical processes to produce pure nickel. But finding this in a natural object from space was unheard of. This led some of the more daring scientists to ask a provocative question. Could this strange chemical ratio be a sign of artificial processing? Was it possible that the material in 3I Atlas was not natural, but had been refined or manufactured by some intelligence? It was a speculative leap, but the data was so strange that it was hard to ignore. The lack of iron was a clue that was almost impossible to explain with standard comet science. It was another anomaly, another unique feature of this visitor that set it apart from everything we have ever known. The chemical mystery deepened even further. Some scientists trying to explain the strange nickel signal came up with an even more exotic idea. They suspected that the object might contain compounds called nickel carbonyls. These are very rare and unusual molecules where a nickel atom is attached to several carbon monoxide groups. Nickel carbonyl is not something you just find lying around in space. These compounds are very unstable. They only form under very specific conditions of temperature and pressure, and they break apart easily when exposed to sunlight or heat. So, to find them in a comet that was travelling through space and getting warmed by our sun would be extraordinary. In fact, these types of compounds are so rare in nature that they are mostly known from industrial chemistry here on Earth. They are used in processes to refine nickel ore and to coat surfaces with pure nickel. They are a product of technology. So the suggestion that 3I Atlas might contain these compounds was explosive. It was another hint that pointed towards an artificial origin. If the nickel was in the form of nickel carbonyl, it could explain some of the strange things scientists were seeing. It could explain why the nickel seemed to be in the gas cloud and not locked away in solid rock. But it also opened up a huge can of worms. If this object contained industrial-grade chemicals, then it was almost certainly not a natural comet. It would be a piece of technology. This theory was highly controversial. There was no direct proof, only hints in the complex light signatures. But it was a theory that fit some of the strange facts. The possible presence of these rare compounds added another thick layer to the mystery of 3I Atlas, pushing the debate into truly uncharted territory. This strange mix of chemicals, the expected and the unexpected, made 3I Atlas a true enigma. On one hand, it had the simple gases of a regular comet, like carbon monoxide. This made it look familiar, like it was playing by the rules. It was the comet part of its disguise. But on the other hand, it had the dust of a rocky planet, a bizarre excess of nickel, and a suspicious lack of iron. These were the clues that suggested something else was going on. It was a chemical contradiction, an object that should not exist. How could one object have such a split personality? How could it be both icy and rocky, both natural-looking and artificially strange? This mix of clues made it very difficult for scientists to agree on what it was. Every theory that could explain one part of the chemical signature failed to explain another. A theory that explained the icy gases could not explain the rocky dust. A theory that explained the rocky dust could not explain the strange nickel-to-iron ratio. The object seemed designed to be confusing. It was a chameleon, showing different faces to different instruments. This chemical puzzle is one of the biggest reasons why the debate about 3I Atlas continues to rage. It is not a simple object with a simple explanation. It is a bundle of contradictions. The mix of familiar and bizarre chemicals adds a deep and compelling layer to the mystery. It is a message written in the language of chemistry, and we are still struggling to translate it. Whatever the true nature of 3I Atlas is, it is clear that it comes from a place where the rules of chemistry are different, or it has a history that is far more complex and strange than any natural object we have ever encountered. The story of 3I Atlas's toughness is perhaps one of its most incredible chapters. On September 25th, 2025, as it was speeding towards its Mars flyby, It had a violent encounter with our Sun. The Sun is not always calm. It sometimes has huge explosions on its surface, throwing massive clouds of charged particles and magnetic energy out into space. These explosions are called coronal mass ejections, or CMEs. They are like giant solar hurricanes, and they can be very dangerous. A CME is a powerful blast of energy. When one hits a planet like Earth, it can cause beautiful auroras, but it can also knock out power grids and damage satellites. When a CME hits a fragile object like a comet, the results can be devastating. And on that day in September, 3I Atlas flew directly into the path of a massive solar flare. It took a direct hit. Astronomers who were tracking the object held their breath. They were watching on their telescopes as this huge wave of solar energy washed over the interstellar visitor. Based on everything we know about comets, they expected to see something dramatic. They were waiting for the comet to break apart. They were waiting for a show. But 3I Atlas had a surprise in store for them. It was not going to follow the script. Its reaction to this powerful solar storm would be yet another clue that this was no ordinary visitor. Its incredible resilience would become another key part of its legend. Most comets are fragile things. As we have said, they are often compared to dirty snowballs or loose piles of rubble. They are held together very weakly. When they are hit by a powerful blast of energy from the Sun, like a CME, they tend to react violently. The sudden wave of heat and charged particles can cause the ice on the comet's surface to vaporize explosively. This can cause the comet to shed huge pieces of its crust, or even break apart completely. We have seen this happen many times with comets from our own solar system. A comet named Ison, for example, completely disintegrated when it passed too close to the Sun in 2013. Another comet, named Atlas, no relation to our visitor, broke into dozens of small fragments in 2020 as it approached the Sun. It is a common fate for comets. They are delicate visitors from the cold, dark edges of the solar system, and they are not built to withstand the violence of being close to a star. So, when the CME hit 3I Atlas, astronomers fully expected it to be damaged. They were watching for signs of fragmentation, for new, smaller objects breaking away from the main body. They expected to see a sudden bright flash as fresh ice was exposed to sunlight. They expected the comet's tail to be ripped away by the solar wind. They expected to see chaos. This was the textbook response of a comet to a solar storm. It was a test of its strength, a test that most comets fail. The solar flare was a giant hammer, and 3I Atlas was the anvil. The whole world was watching to see if it would crack. But 3I Atlas did not crack. It did not break apart. It did not shed huge pieces. Its reaction to the direct hit from the solar storm was completely unexpected. Instead of a violent, uncontrolled explosion, the object responded in a calm and controlled way. As the wave of solar energy hit it, astronomers saw the hazy cloud around the object, the coma, briefly expand. It grew larger for a short period of time, as if it was absorbing or deflecting the energy blast. It was a subtle, measured response, and then, just as quickly as it had expanded, the cloud settled back down. It returned to its normal size and shape, as if nothing had happened. The entire event was over in a matter of hours. There were no signs of damage. The object continued on its path, completely unfazed. It was as if it had just shrugged off the most powerful explosion the Sun could throw at it. This was stunning. It was behavior that had never been seen before in any known comet. It was not the reaction of a fragile, icy rubble pile. It was the reaction of something strong, solid, and incredibly resilient. It was like watching someone get hit by a tidal wave, and instead of being swept away, they just braced themselves, let the water flow around them, and then continue walking as if nothing happened. This incredible toughness was another major piece of the puzzle. It suggested once again that the object was made of something much stronger and more solid than a typical comet. It was another piece of evidence that did not fit the dirty snowball theory. The Unbreakable visitor had just survived a test that should have destroyed it. The object showed no signs of breaking up or fragmenting. In the days and weeks after the solar storm, astronomers searched the area around 3I Atlas with powerful telescopes. They were looking for any debris, any small pieces that might have broken off during the impact. They found nothing. The object was still whole. It was still one single, solid entity. It was as if the solar storm had had no lasting effect on it at all. This was deeply puzzling. How could a comet, an object supposedly made of ice and loose dust, be so strong? Its ability to withstand the blast suggested that it had a very high tensile strength. That is a scientific term for how well something holds together when it is being pulled or pushed. A piece of chalk has low tensile strength. It breaks easily. A piece of steel has high tensile strength. It is very hard to break. 3i Atlas was behaving like it was made of steel, not chalk. Some scientists even wondered if the object had a way of handling the energy. The controlled expansion and contraction of its coma was particularly strange. It was almost as if it had a way to manage the incoming energy, to vent it safely into space without damaging its core structure. Could it have been some kind of natural magnetic field that protected it? Or was it something else? The idea of an object being able to redirect or handle solar energy sounded a lot like technology. It sounded like a feature that would be designed into a starship, like shields on a science fiction vessel. This was, of course, just speculation. But the behaviour was so strange that it invited these kinds of wild ideas. The unbreakable nature of 3i Atlas was a hard fact that was difficult to explain with simple, natural models. This ability to survive and adapt to a major solar event has never been seen in any known comet before. It is a unique and defining characteristic of 3i Atlas. We have a large catalogue of comets that we have observed over hundreds of years. We have sent spacecraft to fly by them and even land on them. We have a pretty good idea of how they are supposed to behave, and none of them have ever behaved like this. This makes 3i Atlas a true one-of-a-kind object. It is an exception to every rule we thought we knew about comets. Its toughness is not just a little bit unusual, it is off the charts. It hints at an incredible origin story. What kind of environment could produce a comet so durable? Was it formed in a place with a very violent star, where only the strongest objects could survive? Or is its toughness a sign that it is not a natural object at all? The resilience of 3i Atlas is one of the strongest arguments against the theory that it is just a normal, if large, comet. Normal comets are fragile. This object is anything but. It is a survivor. It has travelled for millions of years through the harsh environment of interstellar space. It has entered our solar system and taken a direct punch from our sun, and it has not even flinched. This incredible strength is a core part of its mystery. It is a quality that is hard to explain with nature alone. It is a quality that suggests something more, something that lies beyond our current understanding of the universe. The unbreakable visitor continues on its journey, its secrets held tightly within its impossibly strong core. Beyond studying the chemicals in its light, scientists also used a more subtle technique to understand 3i Atlas. They studied how sunlight bounced off the object. This process is called polarimetry. Light normally travels as a wave that wiggles in all directions. But when it reflects off a surface, it can become polarized, meaning the waves tend to line up and wiggle in the same direction. Think of sunglasses that cut down on glare. They work by blocking polarized light that reflects off surfaces like water or a road. By studying the polarization of the light coming from 3i Atlas, scientists could get clues about the texture and shape of the tiny dust particles in its coma. It is another indirect way of seeing what the object is like without actually having a clear picture. When they performed this analysis, they found something very strange. The patterns in the light were not what they expected from a normal comet. A normal comet is made of fluffy, irregular ice and dust particles. When light bounces off these particles, it creates a certain predictable pattern of polarization. But the light from 3i Atlas was different. It was telling a story of a surface that was anything but normal. This was yet another clue, hidden in the very fabric of the light itself, that hinted at the object's strange and perhaps artificial nature. The message was faint, but it was there, waiting to be decoded by those who knew how to look. The light bouncing off the dust around 3i Atlas showed a property called strong negative polarization. This is a very technical term, but the idea behind it is simple. It means that the light waves were scattering in a way that is the opposite of what is normal for icy, fluffy comet dust. Most natural surfaces like sand, rock, or the dust from a typical comet produce a small amount of positive polarization. But the dust from 3i Atlas was strongly negative. This was a major anomaly. It immediately told scientists that the dust particles around this object were not the usual kind. They had to be some unusual shape or made of some unusual material to produce this strange light signature. This was a big discovery. It was a piece of hard data that was very difficult to explain with standard comet models. The strong negative polarization was a clear signal that something was different about the dust from this interstellar visitor. It ruled out many of the simple, natural explanations. Whatever this object was shedding, it was not the ordinary dust you would find in our solar system. The light was carrying a hidden message, a message that said, "My surface is not what you think it is." It was up to the scientists to figure out what kind of surface could send such a strange signal. The puzzle of 3i Atlas was becoming more and more complex. So, what kind of things can produce this strong negative polarization? Scientists turn to their laboratories to find out. They have done experiments for years, shining light on all sorts of different particles to see how it scatters. What they have found is that this kind of light pattern is very rare. It is usually only seen from very unusual types of particles. For example, some tiny particles that have very spiky shapes, like microscopic jacks, can produce negative polarization. Another possibility is hollow shells, like tiny empty spheres. Even tiny metallic flakes, like a kind of glitter, can scatter light in this strange way. All of these possibilities are very different from the fluffy random-shaped dust we expect to see around a comet. Spiky shapes, hollow shells, and metallic flakes do not sound like things that nature would create easily in the cold vacuum of space. They sound more like things that would be manufactured. They sound like technology. This is why the polarization data was so exciting and so controversial. It was an indirect clue that pointed towards the possibility of an engineered origin. Of course, there might be some unknown natural type of dust that can also produce this effect. But based on what we know from our labs, the dust around 3i Atlas looks more like something man-made than something natural. This was a powerful, though not conclusive, piece of evidence. It suggested that the object might be shedding particles that were designed for a specific purpose, not just random bits of ice and rock. These strange light patterns have led some scientists, including Avi Loeb's team at Harvard, to wonder if 3i Atlas has unusual dust shapes, or even surfaces that have been designed. The argument is simple. If the dust looks like something we would create in a lab, we should at least consider the possibility that it was created in a lab somewhere else. This is a very bold claim. It suggests that 3i Atlas might be an alien probe, and the dust it is shedding is not just a natural coma. Perhaps the dust is part of its propulsion system. Or maybe it is a cloud of tiny sensors released to study our solar system. This is deep into the realm of speculation, but it is speculation that is driven by strange and difficult to explain data. The idea of an engineered or artificial origin is no longer just science fiction. It is a hypothesis being discussed in scientific papers because the natural explanations are struggling to fit the facts. The light's hidden message is a key part of this debate. It is one of the few pieces of evidence we have about the physical nature of the object's surface, and that evidence points towards something highly unusual. Whether it is a natural phenomenon we have never seen before or a sign of alien technology is the big question. But the data itself is clear. The surface of 3i Atlas, or at least the material it is made of, is unlike anything we have ever encountered in our own solar system. The indirect evidence also points towards a possible shape for the object hidden inside the haze. By combining all the data, the way it reflects light, the way it moves, and the way its brightness changes over time, some models suggest that 3i Atlas could have an elongated, cigar-like shape. This is interesting because this is the same shape that was suggested for our first interstellar visitor, Oumuamua. An elongated shape is very rare for natural objects in space. Asteroids and comets are usually lumpy and potato-shaped because of random collisions and the pull of gravity. A long, thin shape is not something that forms easily in nature. However, a long, thin shape would be very efficient for a spacecraft designed for high-speed travel through space. It would minimize the chances of being hit by interstellar dust, much like how a needle is harder to hit with a baseball than a beach ball is. A cigar shape would be a very practical design for a probe built to travel between the stars. The fact that 2 of the 3 interstellar visitors we have seen might have this same rare and efficient shape is another major coincidence. It could just be that nature makes cigar-shaped rocks more often than we thought, or it could be another clue that we are not looking at rocks at all. The evidence is all indirect, a puzzle made of shadows and light. But when you put all the pieces together, the strange light scattering, the unusual dust, and the possible elongated shape, it paints a picture of an object that is far from ordinary. It paints a picture of something that might have been designed. As the strange facts about 3i Atlas piled up, the scientific community found itself in the middle of a great debate. One single mystery had given rise to 3 very different theories about what it could be. Each theory tried to explain all the weird observations: the impossible path, the massive weight, the incredible toughness, and the strange chemical and light signatures. But no single theory could easily explain everything. This debate was not just a quiet discussion in university hallways, it was a passionate argument about our place in the cosmos and the possibility of life beyond Earth. On one side were the skeptics, who insisted on finding a natural explanation, no matter how complicated. On the other side were the pioneers, who argued that the evidence was pointing towards something truly revolutionary. And in the middle were those trying to find a third way, a new idea that could bridge the gap. The great debate over 3i Atlas was a perfect example of science in action. It was a process of discovery, filled with disagreement, new ideas, and the slow search for the truth. Let's explore the 3 main theories that have emerged to try and solve the mystery of the unbreakable visitor from the stars. Each one offers a different window into what this object might truly be. The first and most exciting theory is what some have called the Trojan horse probe. This idea suggests that 3i Atlas is not what it appears to be. On the outside, it looks like a comet. It has a hazy cloud of gas and dust around it, just like a normal comet. But this comet-like appearance is just a clever disguise. Hiding inside that dusty cloak, the theory goes, is something else, a piece of advanced alien technology, a long-distance scout from another civilization. The idea is that an alien intelligence might want to send a probe to explore our solar system without being easily noticed. What better way to do that than to hide your probe inside an object that looks like a natural piece of space debris? It would be the perfect camouflage. This theory is called the Trojan horse probe, after the ancient Greek story of the giant wooden horse that was used to sneak soldiers into the city of Troy. In this case, the comet is the wooden horse, and the alien probe is the soldier hidden inside. This idea suggests that the object is mostly natural, perhaps a real comet that was found and then modified. Or maybe the entire object is artificial, but it is designed to release gas and dust to make it look like a comet. Advocates of this theory point to all the strange facts we have discussed. The precise, impossible path looks like a deliberately chosen trajectory. The incredible toughness and ability to survive the solar storm look like signs of advanced engineering and shielding. The strange chemicals and the weird way it scatters light could be byproducts of a propulsion system or other technology. Critics of this theory say that it is pure speculation. They demand more direct evidence of technology. They want to see a radio signal or an image that clearly shows a metallic manufactured object. Without that smoking gun, they say, the alien probe idea is just a fun story. But the supporters of the theory argue that the lack of a signal could also be part of the disguise. A stealthy probe would not announce its presence. The debate rages on, with the Trojan horse theory remaining the most thrilling and the most controversial explanation for 3i Atlas. The second major theory is a bit less dramatic but still very interesting. It is called the planetary seed theory, and it was proposed by a scientist named Dr. Susan Frames. This theory says that 3i Atlas could be a massive natural object that was thrown out of a very young planetary system long ago. In this idea, 3i Atlas is not a comet in the traditional sense. Instead, it is a building block of a planet, a planetary seed. When solar systems are first forming, they are very chaotic places. There are millions of these building blocks, called planetesimals, flying around and crashing into each other. Over time, they stick together to form planets, but some of them can get thrown out into deep space by the gravity of the giant planets in their system. The planetary seed theory suggests that 3i Atlas is one of these ejected building blocks. This could explain some of its strange features. It could explain why it is so massive and so dense. It would be made of the heavy, solid materials that form the cores of planets. This would also explain the presence of rocky silicate grains in its dust. It would be a piece of a rocky planet in the making. This theory is a purely natural explanation, but it suggests that 3i Atlas is a very special and rare type of natural object. It would be the first time we have ever seen a piece of a planet from another solar system. It would be an incredible scientific treasure, a chance to study the raw ingredients of alien worlds. However, this theory is still mostly a theoretical idea. It does a good job of explaining the object's mass and some of its chemistry, but it does not easily explain the impossible path. Why would a random planetary seed have such a precise, flat orbit? The theory also struggles to explain the extreme toughness, as the strange nickel-to-iron ratio. So, while the planetary seed idea is a strong contender, it still leaves many questions unanswered. There is no direct proof for it yet, but it remains an important part of the great debate. The third theory is the most conservative one. It is the idea that 3I Atlas is simply an extreme natural comet. This is the view held by many mainstream astronomers. They believe that we do not need to invent new ideas like alien probes or planetary seeds to explain the object. Instead, they argue that all of its strange features can be explained as rare, but still natural cometary behaviour. In this view, 3I Atlas is just a very big, very old, and very weird comet. Its flat path? A 1 in a million coincidence, but coincidences happen. Its huge mass? Some solar systems must produce bigger comets than ours. Its toughness? Maybe it is made of a strange kind of super strong ice that we have never seen before. The weird chemicals. Perhaps its home solar system had a very different chemical makeup than ours. Defenders of this idea argue that we should always look for the simplest, most natural explanation first. This is a core principle of science. We should not jump to conclusions about alien technology just because something is strange. We should first try to expand our understanding of nature. The problem with this theory is that it has to rely on more and more unlikely coincidences to make everything fit. To explain 3I Atlas, you have to believe in a whole series of 1 in a million chances all happening at the same time, in the same object. It had a rare path, and a rare size, and a rare toughness, and a rare chemical signature. As more strange facts have emerged about 3I Atlas, this theory has become harder and harder to defend. Each new anomaly is another hole in the simple comet story. The supporters of this theory are seen as being responsible and cautious, but their critics say they are suffering from a failure of imagination, unwilling to accept the extraordinary evidence that is right in front of them. The extreme natural comet theory is the safe bet, but it is a bet that is looking less and less likely as the mystery deepens. Every hour that passes, the mystery of 3I Atlas deepens, and our chance to solve it slips further away. This object is not just a scientific curiosity, it is a physical object of immense power, moving through our solar system at incredible speed. Every hour, 3I Atlas travels through space carrying more kinetic energy than any human-made object ever launched. Kinetic energy is the energy of motion. Because 3I Atlas has such a huge mass and is moving so incredibly fast, the amount of energy it carries is truly enormous. If it were to hit a planet, the impact would be catastrophic, far bigger than the asteroid impact that wiped out the dinosaurs. Of course, its current path does not threaten any planets, but its huge energy is a stark reminder of the power of this object. We are not just observing a faint dot of light. We are watching a cosmic powerhouse, a 33 billion-ton bullet fly through our home. This makes the race against time to understand it even more urgent. We need to know what it is and what it is capable of. The clock is ticking. With every passing day, 3I Atlas gets farther away from us, and its secrets travel with it, back out into the endless night between the stars. The chance to get answers is now, and that chance is fading fast. Because of the immense energy it carries, astronomers are constantly watching 3I Atlas for any signs of change. One of their biggest concerns is the possibility that it might break apart. This is an event called fragmentation. As we have seen, the object is incredibly tough, but that does not mean it is indestructible. If it were to break up, it would not just crumble into dust. It would shatter into massive fragments, creating a spray of mountain-sized pieces of debris, all travelling at the same deadly speed of 124,000 miles per hour. This would be an incredibly dangerous event. We would suddenly have not just one mysterious object to track, but dozens of them. It would be like a single cosmic shotgun shell suddenly bursting into a cloud of deadly pellets. This swarm of high-speed fragments would pose a new and unpredictable threat. Their paths could be slightly different from the main object, and some of them could potentially cross the orbits of planets, including Earth, in the distant future. The constant monitoring is therefore a matter of planetary defense. Scientists are using radar and powerful telescopes to check the object's integrity every single day. They are looking for any new objects appearing near it, any sudden changes in its brightness, any sign at all that it is becoming unstable. So far, it remains a single, solid object. But the fear of fragmentation is always there, a shadow that hangs over the ongoing mission to study this strange visitor. The race against time is not just about solving a mystery, it is also about ensuring our own safety. If 3i Atlas were to break apart, the consequences could be devastating. Such an event would release an immense amount of energy. The forces holding the object together would be unleashed in a powerful explosion. This could create a flash of light that would be visible even to amateur astronomers on Earth. But the real danger would come from the fragments. A mountain-sized object travelling at 124,000 miles per hour has more energy than all the nuclear weapons on Earth combined. An impact from such an object would be an extinction-level event. Moreover, the breakup of the main body could alter the paths of the new fragments in unpredictable ways. The outgassing from newly exposed icy surfaces could act like rocket engines, pushing the pieces onto new trajectories. Our ability to predict where these fragments would go would be limited. It would create a new and chaotic situation in our solar system. This is the worst-case scenario, and, while it is unlikely given the object's proven toughness, it is a possibility that scientists must take seriously. The potential for such a devastating event is another reason why the NASA blackout was so concerning. Did they see something during the close flyby of Mars that suggested the object was unstable? Did they see signs of stress fractures on its surface? We do not know. The silence from NASA leaves this terrifying question unanswered. The potential danger, however small, adds a sense of urgency and drama to the story of 3i Atlas. There is one last, best chance to get some answers. The European Space Agency has a mission called JUICE, which stands for Jupiter Icy Moons Explorer. It is a large spacecraft on a long journey to study the giant planet Jupiter and its moons. In November of 2025, the path of the JUICE spacecraft will, by a lucky coincidence, bring it relatively close to 3i Atlas. This will be a critical viewing opportunity. The JUICE probe has a suite of powerful scientific instruments, including high-resolution cameras and spectrometers. It will be able to get a much better look at the object than any telescope on Earth. This encounter offers a final opportunity to get close-up data before 3i Atlas leaves the inner solar system for good. Scientists at the European Space Agency are working hard to prepare for this flyby. They are reprogramming the spacecraft to make sure it is pointing in the right direction at the right time. They will try to get images of the nucleus, study the chemistry of the coma in detail, and measure the object's properties with great precision. The entire scientific world will be watching what JUICE discovers. This could be the moment when the mystery is finally solved. The data from JUICE could confirm one of the three main theories, or it could reveal something entirely new and even more surprising. Everything is riding on this last chance encounter in the cold, dark space on the way to Jupiter. Once 3i Atlas passes Jupiter and moves into the outer solar system, it will fade from our view. It will become too distant and too dim for even our best telescopes to see. It will continue its journey, heading back out into the vast emptiness of interstellar space. And once it is gone, the chance to uncover its secrets may be lost for generations or even forever. We will be left with the data we have, and the unanswered questions will remain. This is why the current moment is so crucial for science. The window of opportunity to study this object is closing. The race against time is real. We are living in the few short months when this messenger from another star is visiting our neighbourhood. What we learn now will shape our understanding of the universe for decades to come. Will we remember 3i Atlas as a strange natural comet, a rare planetary seed, or the first confirmed sign of a technology from beyond our world? The answer depends on what we can discover in the little time we have left. The story of 3i Atlas is a reminder that we live in a vast and mysterious cosmos, and that we have only just begun to explore it. The secrets of the stars are out there, and sometimes they come to visit us. The silence from NASA, the impossible path, and the unbreakable nature of 3i Atlas. Are these just strange coincidences, or something far more deliberate? What do you think 3i Atlas really is? Share your theories in the comments, and join the investigation into this cosmic enigma.